we saw in the last unit that there are spreading ridges out in the ocean that are making seafloor that moves away from them, and it might have bothered you at that time. The Earth is not in being blown up, inflated like a giant balloon. So if we're making seafloor all the time, where does it go? And the answer is it goes back into the Earth to replace what is coming out at subduction zones. And this is a diagram of a subduction zone that we have swiped from the United States Geological Survey. It has a number of details, maybe more than we need. But the downgoing slab, the friction that it makes, tends to drag down the seafloor and make low spots that we call trenches. Those are often filled with very deep water, the deepest spots in the world ocean. But sometimes they get filled with sediment, and you see the accretionary wedge there. That's the scraped off stuff. And sometimes the scraped off stuff can make a little coastal mountain range. We'll see that at the Olympic and the coast ranges of California. You also end up in such systems that the downgoing slab takes down some water. The water lowers the melting point of the deep rocks, and that allows magma to rise and then to feed volcanoes. So you have these volcanic arcs running along parallel to the trenches. And you also find in such systems that there's a lot of sticking and slipping and sticking and slipping that makes earthquakes as you go down. So these are features that you see in subduction zones. Now, where do you find subduction zones? A lot of them are lined up around the Pacific Ocean in what we call the Ring of Fire. And so you can see a diagram of the Ring of Fire here. These blue things are the trenches, including the deepest water in the world ocean at the Challenger Deep. There is another trench over here. It just happens to be full of sediment, so you don't need to worry about this. And later we'll sing about the Ring of Fire. So there's the Ring of Fire for you. Now we'll take a better look at this, a little more detail and more data. There's a lot of things in this figure. First of all, if you come over here on the right towards the Caribbean, you'll see this big red band, and there are several of such big red bands on this. These are the subduction zones that are close to the U.S. Holdings, so that's near Puerto Rico and the Virgin Islands, and they're part of the U.S. And so these are near U.S. land. And these are a special concern of the United States Geological Survey, which made this map. If we then look at other things on this map, there is some more red on here, and that's little tiny red dots, and you'll see a whole bunch of little tiny red dots, for example, just below what I drew there at the top. All of those little red dots are volcanoes. And you see volcanoes in the Aleutians where I was, you see them out in the Cascades, you see them in central Mexico, you see them in Central America, you see them down the Andes. There's a whole lot of places around here that you can see volcanoes popping up. Also on this plot, you can see earthquakes. So the black dots, such as the ones just inland from where I'm drawing down in the lower right there next to South America, those are all earthquakes. So this plot is showing you where the earthquakes are and where the volcanoes are, which ones are on the U.S. The very light red line out in the middle, these are the spreading ridges. And then later we'll come back and we'll look at Hawaii and the hotspot chains. But so now you can get a pretty good view of what many of the features are that we have to worry about when we talk about the Ring of Fire. We're going to do one more view of things here. This is a figure that was generated by Gavin Hayes, who is a graduate of Penn State and works for the United States Geological Survey. And what's shown here is not just the Pacific Ring of Fire, which is sort of over around this, right? So that's in the Pacific. Now you see all of the subduction zones on the planet. And the funny sort of coloring here, the yellow, the zeros, mean that the downgoing slab, the downgoing seafloor has just started down. It's right at the seafloor. And you'll see it, say, over where I'm drawing now, it starts down under South America there. The deeper one, 600 kilometers, that's 400 miles almost. And it goes down and gets deep most of the way under South America towards the Atlantic. You can similarly see other places that the slabs are going down from shallow to deep. And this one you'll also see the subduction zone that's contributing to Vesuvius and Etna and to pushing up the Alps there. So we're going to look at subduction zones here.